Hello and welcome back to Atomic Math. Today we're going to do some practice problems and use some of the skills we've learned. We're going to do 3 problems, 1 math, 1 physics, and 1 chemistry. Let's get started. We're going to start with the math problem. And we're going to do a word problem because that's where students often have trouble. It's not just about being able to do the math, it's about being able to figure out how to set up the question. So let's look. A school sold 120 tickets for a fundraiser. Student tickets cost $8 each, and adult tickets cost $12 each. The total amount of money collected was $1,200. So how many student tickets and how many adult tickets were sold? So the first thing that we need to think about here is how we're going to go about solving the problem. This isn't about thinking about which one of the formulas that I've learned am I going to use. Sometimes it's simpler than that. So the first thing that you want to do is look at, what do I need? What am I trying to find? Well, we're trying to find how many tickets were sold by both adults, for both adults and students. So let's let S be the number of student tickets sold, and we know that they were $8 each. And we'll let A be the number of adult tickets sold, which we also know was $12 each. Now let's look at what we already know. We know that we sold a total of 120 tickets, and we know that the total money collected was $1,200. So let's just start building some facts. Don't even think of them like equations, okay? If I sold 120 tickets, then that means some combination of the adult tickets and the student tickets has to equal 120. So I can create this equation right here that says S plus A must equal 120. So that means that if I wanted to, let's say, have this in terms of just one variable, like this, I could minus A off of both sides, and that would get me down to just this. So now I have that same equation, but in terms of S. So we will call this equation 1. Now, as we mentioned, we also know that the total money collected was $1,200. And we know the price of the student tickets and the price of the adult tickets. So we can set up this where we can say, we don't know how many student tickets were sold, but if however many it was, we times that by $8, plus however many adult tickets we have, and those are going to be multiplied by $12, that's going to come together to be our $1,200 that we collected. This is going to be equation number 2. And as you can see, in equation 1, we rearrange that so it could be expressed in terms of S. So now we're just going to sub equation 1 into equation 2. So instead of S, we're going to put 120 minus A, and then we're going to times that by $8, plus A times $12, $1,200. If we multiply that out, we're going to get 960 minus 8A plus 12A equals 1,200. So if we collect the like terms and move the 960 to the other side, we're going to have 4A equals 1,200 minus 960, which gives us 240. So we just need to divide that by 4. And now we know that we sold 60 adult tickets. We just take that value and sub that back into equation 1. And we know that the student tickets was 120 minus 60, which gives us 60. So we sold 60 adult tickets and 60 student tickets. As you can see, the math that I used was very simple. There was nothing complicated there. We didn't even have exponents, nothing. But if you didn't know how to set it up, you wouldn't have been able to solve the problem. But as you can see, I didn't use an equation that already existed. I just used facts and common sense. And that's the place where students struggle because they see a problem. And honestly, the simpler the problem, sometimes it's the harder problem for the students because they think it must be more difficult. So if you're starting one of these problems, write down what you're looking for, write down what you know. And even if you don't know the plan for how you're going to get to your answer, just start writing things down like, okay, well, the adult tickets and the student tickets together has to total 120. And I know the amount made, so some combination of $8 tickets and $12 tickets is going to be 1,200. And keep writing this down and then move one of the equations so it's solved in terms of one variable, and then you can use it to substitute into the other equation, and before you know it, you'll have your answer. So don't overthink, I guess is probably the thing I'm saying here. Just think logic, don't think math, okay? Let's take a look at a physics word problem. Okay. A car travels at a constant speed for 2 hours. Then it increases its speed by 20 kilometers per hour and travels another 3 hours. The total distance traveled is 260 kilometers. What was the car's original speed? Now, just like with the math, this type of physics question confuses students because they feel like they don't have enough information or they just don't even know where to begin. So we're going to do the exact same thing. We're going to write down what do we want and what do we know. So first of all, we're trying to find this original speed. So let's let v be the original speed. We know that the total distance traveled was 260. And we also know, just by common sense, don't even have to think about it as a formula, that the distance traveled would be the speed and then how long we traveled. So speed times time. So we have these three things to start with. So let's look at the first 2 hours of the journey. And in that time, whatever the distance, we don't know what the distance is that the car traveled, but we can write it like this. Whatever the distance is, it was 2 times 2 hours times the speed that we were traveling, which we also don't know. That's fine. Don't worry about how many things you don't know. Just start writing things down. That's going to be our equation 1. Now, in the last 3 hours, we can write the distance as 3 times the speed that I was going in those 3 hours. Now, we don't know what it is, but we do know that it's 20 kilometers per hour more than I was going in the first 2 hours. So we can express that as v plus 20. Okay, that's going to be our equation 2. The whole journey was 260 kilometers. So we can create an equation like this where we say the total distance was the first part, the 1 plus the 2. And we know that that's 260. So that means that we can create an equation and set it up and equal it to 260. So we put basically equation 1 in, and then we add equation 2, and we set that equal to 260. So now we just have to multiply that out, and we get 2v plus 3v plus 60 equals 260. And we're going to collect the like terms and move the 60 over. And we have 5v equals 260 minus 60, which of course is just going to be 200. So if we divide out the 5 from both sides, we're going to get 40 kilometers per hour. So that was pretty simple. And it might have seemed like a very difficult question. But like I said, all we used here was the information they gave us and not even a true physics formula, just common sense. Distance that you travel, well, how fast were you going and how long were you driving, right? So you don't always have to think about things in like complicated ways. Sometimes just use common sense. So we know that the original speed of the vehicle was 40 kilometers per hour. If they had asked us, well, what were you traveling for the last 3 hours? Well, that's easy. We would just add the 20 kilometers per hour, and we have 60 kilometers per hour. So we spent 2 hours at 40 kilometers per hour and 3 hours at 60 kilometers per hour. Okay, now we're going to look at a chemistry problem, also a word problem. You have a solution that is 30% salt. You have 200 mils of this solution, but you need 100 mils of a solution that is 20% salt. How much water do you need to add to make a 20% solution? So again, you're not looking for some special formula. We're just going to write down what we want and what we know. Well, we want to know the volume of water we need to add. So let's let X be this unknown value of water that we need to add, okay? We know that when we add that water to the 200 mils, we're going to have a final volume that's something different. So let the V be the final volume of our 20% solution. We also know that the initial volume of the 30% solution is 200 mils, and that the concentration is 30%. And we also know that the final concentration has to be 20%. So now we've written down what we want and what we know. Okay, first thing that we have to figure out is in that 30% solution that we have 200 mils of, how much salt is in there? So in order to calculate that, we're just going to take basically 30% of those 200 mils. So 0.30 times 200 equals 60. So we'll say we have 60 mils of salt. In the final solution, which we want to be 20%, we could write that as 0.2 equals those 60 mils of salt over some volume that we don't know yet. That's our final volume. Okay, so this is going to be our first equation right here. Now we know, just based on sort of common sense, that the final volume is going to be 200 mils plus this X, this value of water we added that we don't know what it is yet. So that's going to be equation 2. So we can sub equation 2 into equation 1. So we can fill in the bottom of that fraction. 0.20 equals 60 mils over 200 mils plus X. Now we can solve for X because we don't have any other variables in there. We just have one variable. So let's get rid of this fraction. Let's bring the bottom up. So we have 0.20 multiplied by 200 mils plus X, and that equals 60. So if we multiply that 0.20 through, we're going to get 40 mils plus 0.2x equals 60 mils. If we take our 40 mils to the other side, we're going to have 0.2x equals 20 mils, which means x is 100 mils. So 100 mils of water must be added to get the final concentration of 20%. And obviously, if I add 100 mils, my final volume is going to be 300 mils. Again, not very difficult. I definitely didn't use difficult math. The most complicated thing here was a fraction. But you had to create it yourself. You had to think it through. And that's the thing that most students struggle with, is knowing how to solve the question or knowing where to begin. And that's why I always tell students, don't worry about where to begin. Just write down, what do I need to find and what do I know? And then just start playing with that. Maybe the first few things you come up with you can't even use, but that's fine. Just start writing some things down, see what can I come up with this information, okay? Now I want to point out one other thing, because this happens to students a lot. You may or may not have noticed that there was some information in that question that I didn't use, and it's this right here. It said that I needed 100 mils of the solution, the 20 mil solution. That has nothing to do with this calculation. It's merely part of the story. And sometimes when students are reading one of these questions, they think they have to use every piece of information in the question. But in this case, you can see that this 100 mils is going to come out of that final solution, but it has no bearing on the calculation of how I'm going to get to that solution. So like I said, it's just part of the story, but a lot of students will try to find some way to use that value. So remember that you don't always have to use every bit of information in the question. It may just be part of the story. So you need to look at what parts do I need, and then ignore the rest, okay? So basically we saw here that we had 3 different questions in 3 different subjects, but we used the exact same skill. And what we were doing wasn't just practicing what we knew already, we were actually getting a new tool for our toolbox. And that tool, that was logic. Because that's probably one of the most important things that you can have when you're trying to do math, physics, chemistry, any science really. As I mentioned, those really simple questions, those are the ones that really confuse students because they think that it must be more complicated than that. But it's not always complicated. Sometimes it's simple. Sometimes it's just simple logic. It doesn't even need the use of complex math or physics. You just need to think. And for some reason, people kind of blank when it comes to math. They think it's a different thing. But for example, average in math is exactly the same as average you use in real life. You add things together and divide by how many things you have. So there's so many things that people can do in their regular life that once you put it in the box of math, they think they can't do it, but you can. If you found this video helpful, go ahead and hit like. And if you want to see more videos like this, hit the subscribe button. And in the next video, we are going to look at trigonometry, which some people are scared of. But we're only going to look at the pieces that we need, so we won't be doing all trigonometry, just the stuff that we need to basically work with vectors. So, see you next time.